Topic 1.2, Uncertainties and Errors. So in this topic, we're going to begin to think about how experimentation is done and what some of the limitations of experiments. As human beings, we certainly are not perfect, and no measurement that we could make could possibly be perfect, and so that means that any experiment we conduct, there will be errors in some of the measurements that we have made. So it's really important as a scientist to think about the kinds of errors that might be there, how might we identify that those are present, and most importantly, how could we reduce or hopefully eliminate some of those errors. We essentially break the errors down into two different types, I should say, random and systematic. And then there's a lesser type. Random and systematic often are in the data. The third type, the subtype, the reason why it's considered a subtype is because it's not always present in the data. It's oftentimes when we make our original raw measurements, there's a reading error, but oftentimes in the finished product, the reading error is essentially irrelevant. So let's start by looking at the least important of the errors, and that is the reading error. The reading error is very simply the idea that any instrument that you could read is limited in their ability to make a measurement. So in other words, what that means is that at some point we are going to have to read between the lines. So using a ruler as an example, the picture on the right shows a measurement with 0 right here, and this is unfortunately it's in inches, 0, 1 inch, 2 inches, and obviously if we look at where this piece that they're measuring ends up, it ends up between 1.5 and 2.0. So that means that we can either say that it's 2 or 1.5, or we can do something a little bit better, which is to try to read between the lines. It's really important that you at least attempt to read between the lines to produce what we would call the most precise measurements that you can make. So I might suggest this is 1.7. So my choices of what number would I record is I could say it's 1.5 or 2.0. I could not read between the line and simply record the number above or below it, whichever one it happens to be closest to. Or I can try and estimate that number. Now, estimating the number introduces what we call the reading error. But I think it would be easy to argue that it would be better to have that reading error than to say that this measurement is 1.5 or 2.0. It's clearly neither of those. So although by trying to estimate I'm introducing some error, it's actually less error than if I just go ahead and use the crude measurements and I just say whichever marker on the ruler that it's closest to, that's the number. So it's a little strange that we actually want to estimate or read between the lines knowing that that will introduce error, that it actually overall it reduces the reading error by trying to read between the lines as precisely as possible. So the reading error is a number. Whenever you give a measurement, you would give a plus or minus number called the uncertainty. And the reading error is one way of figuring out what your uncertainty in a measurement is. So that brings up the different types of devices that you can use to make measurements, and there's really two types that we need to think about. And these are digital and analog. Now, until recently, we didn't have digital instruments for very many of the things that we would make measurements, but today, in today's age, the digital devices are almost more common than the analog. Digital devices means that it has an electronic reading. Okay, so for an example, this is a electronic thermometer, and the reading error on a digital device is really simple. It's essentially one of the last division that we can read. So in this case, that would be one place after the decimal or the tenth position. So we would say that the reading error for this device is 0.1 degrees Celsius, because that's one of the smallest unit that it can read. Stopwatch is another very common device that you'll use in physics class, and so that gives you time out to 100th of a second. So in that case, we would say the reading error would be 0.01 seconds. So for digital, it's pretty easy. This is the convention, is that we use one of the smallest division. In the analog devices, it's a little bit different though. For the analog devices, and we'll use the ruler as an example. So in this one, the smallest division is 1 millimeter. So we might say that the reading error is as large as 1 unit. So I could say it's plus or minus 1 millimeter. But reasonable person, I think it would be reasonable for me to expect that you would at least try to read between the lines. It's a very challenging thing to do. So what oftentimes the reading error is listed as is half of the smallest division. What that's essentially saying is you could look at a measurement and you could tell, was it on the line or was it somewhere in between the line? If it's in between the line, we're probably going to say that it's 0.5 over, and if it's exactly on the line, then we're going to say it's exactly that number of millimeters. So in this case, this line represents 71 millimeters. Now, reasonably though, the problem with the reading error is that it's not just a product of the instrument, it also depends on the person who's reading it. Now, no one reading this digital thermometer is going to read anything different than 12.8. But when we bring a ruler like this in, you'll find that 10 people measuring the same object, if they're trying to read between the lines, you may very well have 3 or 4 or 5 or maybe even 10 different measurements based on their interpretation of reading between the lines. So as a result of that, the reading error in an analog sense actually it's variable. You have choices. Generally speaking, you would never make it more than 1 millimeter. You can certainly read which millimeter line this is on, but you would not suggest that you could probably read less than 1/10 of that division. Now this could be 1/10 of anything. It could be 1/10 of a degree on a regular thermometer. On a regular thermometer, the degrees are pretty small, and so 1/10 of that would be 0.1 degrees Celsius. That's a pretty small division to read. Even smaller, reading between the millimeters, 0.1 millimeter is pretty small, but if you as the experimenter feel that you have that precision, that you have that experience to make that measurement and you can accurately read it to the nearest tenth, then you could certainly list your reading error as being 0.1 millimeter. So it's a little bit at the disposal of the person who's making the measurement to decide for the analog devices what's the reading error, but you're typically going to pick 1 unit as the biggest number, the lowest number being maybe 1/10 of a unit. Probably most often most people will pick half of the smallest unit. In this case, that's half a millimeter.